In descriptive statistics, a boxplot or boxplot is a convenient way of graphically depicting groups of numerical data through their quartiles. Boxplots may also have lines extending vertically from the boxes indicating variability outside the upper and lower quartiles, hence the terms box-and-whisker plot and box-and-whisker diagram. Outliers may be plotted as individual points. Boxplots display variation in samples of a statistical population without making any assumptions of the underlying statistical distribution. Boxplots are non-parametric. The spacings between the different parts of the box indicate the degree of dispersion and skewness in the data, and show outliers. In addition to the points themselves, they allow one to visually estimate various L-estimators, notably the interquartile range, midhinge, range, mid-range, and trimean. Boxplots can be drawn either horizontally or vertically. Types of boxplots. Box-and-whisker plots are uniform in their use of the box. The bottom and top of the box are always the first and third quartiles, and the band inside the box is always the second quartile. But the ends of the whiskers can represent several possible alternative values, among them, the minimum and maximum of all of the data, the lowest datum still within 1.5 IQR of the lower quartile, and the highest datum still within 1.5 IQR of the upper quartile, one standard deviation above and below the mean of the data, the 9th percentile and the 91st percentile, the 2nd percentile and the 98th percentile. Any data not included between the whiskers should be plotted as an outlier with a dot, small circle, or star, but occasionally this is not done. Some boxplots include an additional character to represent the mean of the data. On some boxplots a crosshatch is placed on each whisker, before the end of the whisker. Rarely, boxplots can be presented with no whiskers at all. Because of this variability, it is appropriate to describe the convention being used for the whiskers and outliers in the caption for the plot. The unusual percentiles 2%, 9%, 91%, 98% are sometimes used for whisker crosshatches and whisker ends to show the 7-number summary. If the data is normally distributed, the locations of the 7 marks on the box plot will be equally spaced. Variations. Since the American mathematician John W. Tukey introduced this type of visual data display in 1969, several variations on the traditional box plot have been described. Two of the most common are variable width box plots and notched box plots. Variable width box plots illustrate the size of each group whose data is being plotted by making the width of the box proportional to the size of the group. A popular convention is to make the box width proportional to the square root of the size of the group. Notched box plots apply a notch, or narrowing of the box around the median. Notches are useful in offering a rough guide to significance of difference of medians. If the notches of two boxes do not overlap, this offers evidence of a statistically significant difference between the medians. The width of the notches is proportional to the interquartile range of the sample and inversely proportional to the square root of the size of the sample. However, there is uncertainty about the most appropriate multiplier. One convention is to use visualization. The box plot is a quick way of examining one or more sets of data graphically. Box plots may seem more primitive than a histogram or kernel density estimate, but they do have some advantages. They take up less space and are therefore particularly useful for comparing distributions between several groups or sets of data. Choice of number and width of bins techniques can heavily influence the appearance of a histogram, and choice of bandwidth can heavily influence the appearance of a kernel density estimate. As looking at a statistical distribution is more intuitive than looking at a box plot, comparing the box plot against the probability density function for a normal n, 0, 1 I2 florins, distribution may be a useful tool for understanding the box plot. See also, bivariate boxplot, exploratory data analysis, fan chart, 5-number summary, functional boxplot, violin plot, references. Further reading, John W. Tukey. Exploratory Data Analysis. Addison Wesley, Benjamin I. Why Opening the Box of a Boxplot. The American Statistician 42, 257 Euro 262 doi, 10.2307/2,685,133. JSTORA 2,685,133 Rusi, P.J. Rutz, I. Tukey, J.W. The Boxplot, a bivariate boxplot. The American Statistician 53, 382 Euro 387 doi, 10.2307/2,686,061. JSTORA 2,686,061 External links, visual presentation of data by means of boxplots, online boxplot calculator with explanations and examples, BSM boxplot, superimposing a frequency jittered strip chart on top of a boxplot, complex online boxplot creator with example data, see also Boxplot, a web tool for generation of boxplots. Spitzer al. Nature Methods 11, 121 Euro 122.